Okay, so here we have two examples of scientific notation. You can see we have a very large number and we have a very small number. So this is two examples of why we would use scientific notation. So we can see there's a coefficient on each one. So this is the number, and it's always going to have a number between 1 and, it says between 1 and 10, but it's between 1 and 9 because it can't be 0 on the front and it can't be 10. It can't be a two-digit number. It has to be a one-digit number. So we move the decimal place over until we get to that one essential number. That's called our coefficient. We always have it times a base of 10, and the exponent actually tells us is it a big number or a small number. So if it's a positive exponent, it's a large number. If it's a negative exponent, it's a small number. So it tells us it's a decimal or it's not a decimal. Really, that's what the exponent lets us know. All right, so we are finishing our computing with scientific notation section. And in this one, we are going to look at adding and subtracting in scientific notation. So this one's a little different than multiplying and dividing. I think multiplying and dividing are a little bit more simple because you literally just multiply or divide the coefficients, and then you either use the power rule or the the power rule or the quotient rule. I still said that wrong. Product rule or quotient rule to either add or subtract the exponents. When you're adding or subtracting scientific notation, the powers need to be the same, and then we can simply add or subtract leading numbers and include the power of 10 because it's already the same. So with this one, it's not the same. First, we have to change the power of 10 if it's not already the same. So we're going to practice it being the same, and then we're going to practice it being a little different so that we can see both of them. But if they are the same, hey, that makes it very easy when they're the same, and you can just add those coefficients, 5 plus 4, and that gives me 9, and you just tack on the power of 10. You don't actually add those. You're not multiplying the two, you're adding them. So these kind of act like a variable almost. They just kind of get tacked on. So when the powers of 10 are not the same, we first have to make the powers of 10 the same. So 2.6 times 10 to the 6th plus 4.396 times 10 to the 8th. So we can see 6 and 8, those are not the same powers. So we need to make them the same. So we're going to come over here to this kind of sloppy line, and this is taking this 8th power and we're going to turn it into the 6th power. So what we're going to do is we're going to look at this 4.3610, and to go from 8 to 6, I need to take 2 away. So I'm separating 2 and 6. And what that means is I'm going to take this 2 and I'm going to move the decimal point over 2 times. So I'm going to kind of expand that out a little bit. And now I can put it back into my equation, so I'm just replacing. But they both have the 6. So now I can just add those coefficients just like I did on that first one. So you can see 2.6 plus 436.9, and then they'll have times 10 to the 6th power. So if I click here so we can actually see the next piece here. So we get 439.5 times 10 to the 6th power. Well, 439, that's not scientific notation. I do in fact need to move that decimal point back over 2 times, okay, so that I can add the 2 back, because I took the 2 away by not fully putting it into standard notation, but I kind of partially did with just that 2. So I have to put it back so that I have 10 to the 8th power. So we could have also manipulated this one to be to the 8th power, and then we wouldn't have had to make this slight adjustment at the end. It's not always obvious which one is going to be the better option. So you may change one and then realize, oh, I'm going to have to change it again to fix it at the end. So it just kind of depends on which one you choose there. But it's not necessarily a big deal. We just have to make sure when we end, this scientific notation, or the number in the front has to be a number 1 to 9. It can't be 0, and it can't be a 2-digit number. Alrighty, so let's go ahead and practice. Okay, so we have one with the same exponents and one with different. So we have 4.5 times 10 to the 8th power plus 3.1 times 10 to the 8th power. So write your answer in scientific notation. So since we have 10 to the 8th power on both, we can kind of think of that as, a variable, the same idea when we're doing like terms. They're the same. So I can add the coefficients. I have 5.4 of them here. I have 3.1 of them here. So I can just add my coefficients. 4.5 plus 3.1, that gives me 8.5. and then I can just tack on that times 10 to the 8th power. So that one is all done. Let's go ahead and practice this one. So we're subtracting this time. So I do want to subtract the coefficients, but first I need to make sure that these exponents match. So I have 9 and 6. They don't match yet, so I'm going to take the 9 and I'm going to bring that down to 6. So to go from 9 to 6, that means that I'm going to need to move that decimal place 3 times, and I'm bringing it down, so I'm going to move to the right so that we can subtract 9 and 3 to get to 6. So I'm going to move that decimal place 3 times. I'm going to kind of unexpand it. Oh, those went out of order a little bit. That's all right. So I'm taking 3 away by moving 3 units to the right. So remember, when I'm putting it into standard notation, I'm moving to the right, which means that the exponent's going down. Every time I jump 1, it goes down 1. So now I have 8,540 times 10 to the 6th minus 2.9 times 10 to the 6th. So now I can subtract those coefficients because we have the same power of 10. So when I subtract, I get 8,537.1 times 10 to the 6th. That is not in correct format. I can't have this 8,000 in front. I need to move this decimal so that it's right here, right before the 8. So I'm going to jump it back 3 times. And so now, because I'm going from a large number to a smaller number, I'm putting it into scientific notation. I'm going to add 3 back to the exponent. So I go from power of 10 with the exponent of 6. I'm going to add 3, so now I have an exponent of 9. And I do need to make sure I include all of these numbers because they are all essential numbers. There's no just zeros on the end that I can drop off. One thing I did want to make sure that we understood is why do we have to make the powers of 10 match? So this is the same idea. Adjusting the power of 10 to match is like lining up your columns in regular addition and subtraction, right? So if we looked at those numbers that we were just looking at a second ago, we would have, let's see, what is this? Billion, 8,540,000,000, and then 2,900,000 for the second one. So these are the two numbers we were just looking at. Well, if I write them in standard notation like this, I wouldn't line them up this way. This doesn't make sense. I need to make sure I scooch this one to the end so that the decimals are lined up. Oh, that just all animates very quickly. So we wouldn't want to subtract the 8 and the 2. That's billion. This is million. They're not the same column, right? So I want to make sure that I scooch these over when I subtract, and I can subtract straight down like that. So really changing the number here is just making sure that we're kind of lining up those columns in a way. We're making sure we're talking about the same size number because this is 8.45 billion and this is 2.9 million. So basically when I made this a 6 on that last one, I turned it into millions. So now we're talking about the same type of number, the same size number, instead of 2 different size numbers, because billion and million are very different. All right, so that was adding and subtracting in scientific notation. I hope that helped, and I'll see you in the next video.